Lesson 4.7 is on an idea called completing the square. We actually do take 2 days to talk about this. And what you complete the square, it's an action, it's something that you do. If you are going from standard form, remember that's your ax squared plus bx plus c, you can complete the square, and in the end, you'll end up with vertex form. So why is that helpful? Well, a few different reasons why. It's really easy for us to solve for x over here in vertex form. Also, it's really easy for us to graph in vertex form. So completing the square is just a way to get from standard form into vertex form. The book likes to kind of lead you into what you do for completing the square, what the idea is. So we start with the idea of a perfect square trinomial. So here we have 3 trinomials. These are all in standard form, and basically we're looking to factor these. And so what do these look like in factored form? Well, you would look at this 9 and say, what are factors of 9 that add up to 6? And hopefully you guys are saying, oh, well, a 3 and a 3. So that's going to factor into x plus 3, x plus 3. And then, I haven't stressed this yet, but now it's going to be important. Anytime that you have the same, something multiplied by itself, we know that that's the same thing as squaring something. So we'll say x plus 3 squared. Now it kind of looks a little bit like vertex form. So kind of, by factoring, we're able to get, and this works only with perfect square trinomials. Perfect square means that this last number here is going to be one of those perfect square numbers, 4, 9, 16, 25, 36, all of those. But if it's a perfect square trinomial, it's going to factor into this pattern every time where in the end you're going to have a binomial squared. If we take a look at the next example really quickly, how is this going to factor? Well, factors of 25 are 5 and 5. So we know it'll be x plus 5, x plus 5. And then we're multiplying the same thing by itself, so x plus 5 squared. So if you have a perfect square trinomial, it's going to factor into this every single time. This next one, maybe we can kind of skip through a step for a second. Let's see if we can jump to the end. You have 144, so factors of 144 that add up to a negative 24. So that's going to be a negative 12 and a negative 12. Well, we know that we could write it this way, x minus 12 times x minus 12, but it's going to end up in this last step, so maybe we can just skip to that and say, okay, well that'll be an x minus 12 squared. That's what we're going to do a little bit of when we complete the squares. We're going to be able to skip to this step right here. So we're not always given a perfect square trinomial to work with, so part of what completing the square will do is it will have us create a perfect square trinomial, something that we know we can factor, like we were just doing in that last slide. So here's how we create a perfect square trinomial. If you take this middle term, this number 8, and if you cut it in half, so divide it by 2, and we get 4. And then if you square that 4, that's the number that makes that a perfect square trinomial. Now it's an x squared plus 8x plus 16. That's a 16. And then does this factor? Well, do we have factors of 16 that add up to 8? Yeah, 4 and a 4. And so x plus 4 times x plus 4, or just x plus 4 squared. This is a perfect square trinomial, and once we have that, that's how easy it is to factor those. So the idea is, how do you figure out what number should be your c value so that you have a perfect square trinomial? And again, let me run through another one with you. All you do is you take your middle term, your b value, and you first cut it in half. And this will work every single time. That's going to give you a negative 6. But then you're going to have to square it. That's the number that goes up here. A negative 6 squared is a positive 36. So we have x squared minus 12x plus 36. This is factorable. It's going to factor into, try to think about what it will be, x minus 6 squared. So part of what we do when we complete the square is we do come up with this c value. What can we put here that's going to give us something that we can factor really easily? Here are your steps for completing the square. You definitely want to have this down in your notes. And I will go through an example with you to kind of make sense of it. But first, step 1, you're going to slide your c value over 2 spaces. Step 2 is you find your b value divided by 2. We were doing that on the last slide. And then you square it. Write that value into the first space. Step 3 is counterbalancing in the second space. In step 4, you write your perfect square trinomial as a binomial squared. That's the factoring piece. And then you combine your like terms on the end. So, pause the video for a second, get all that written down, and then we'll go through a couple examples. Alright, when you complete the square, that first step is to slide the c value over 2 spots. What we're given, this is not a perfect square trinomial. There are no factors of 5 that will add up to, it's just not a perfect square trinomial. It might be factorable, but we're not going to worry about that right now. So first step is we always have to get this c value over, because we don't deal with it till the very end. So those 2 spaces, we have x squared minus 6x. We actually do write in 2 blanks, and then that plus 5 on the end. And that helps us figure out what is it that we're going to put into these 2 spots. Our goal is going to be to create a perfect square trinomial right here, something that we can factor. So you take your b value, that negative 6, and divide it by 2. So negative 6 over 2 is a negative 3. And then we have to square it. When we square it, that's going to be the number that goes there. So negative 3 squared is a positive 9. I don't even remember what step that is already. Maybe step 2. Step 3 is to counterbalance. We just added in a 9 to our equation or our function, whatever we're talking about. We just totally threw everything off by adding in a 9. So the second space is where you get to counterbalance that. Well, if you add in a 9, we counterbalance by subtracting a 9. And really, that means the only thing we put in, a positive 9 and a negative 9, is just a value of 0. We haven't changed anything. We're able to manipulate it so that we can get it into vertex form really easily. Alright, so the last step is to factor this. This x squared minus 6x plus 9, that's factorable. We on purpose made this something that we could factor. We made it a perfect square trinomial. So what are factors of 9 that add up to a negative 6? Well, that's your negative 3 and negative 3. So that's just going to become an x minus 3 squared. By the way, what you'll also notice, your b over 2, this negative 3, is always the number that goes right there, every single time. And then last thing we have to do is just combine these terms on the end, this negative 9 plus 5. Well, negative 9 plus 5 is a negative 4, so minus 4. And now it is in vertex form. Anyone could walk in and say, oh, well, that vertex, tricky x is a positive 3, negative 4. And then they could start graphing. A value is 1 out front. But basically, that's what you're going from standard form to vertex form looks like. I'm going to go through just one more example with you. There are videos to watch on this, and it's kind of it's a pattern that you get down for how to approach this problem if you're completing the square. Now we're going to complete the square, but then go ahead and solve the equation, because it gives us another way to solve, which is great. We can solve a quadratic by completing the square and then solving. One thing, make sure that you are equal to 0. That's what we've been doing earlier in the chapter, so that shouldn't be a new idea. And we're going to complete the square first. So we start by putting in those two spaces. We'll do x squared plus 8x space, and that minus 3 goes on the end. And now we want to turn this into a perfect square trinomial. So we take our b value and we divide it by 2, and that gives you a 4. And then you have to square the 4, that's the number that goes up there. So 4 squared is a 16. We add in a 16. This is factorable. We just created something we can factor. But we also added a 16 into our equation, which means we have to subtract a 16 also. When we rewrite this, this x squared plus 8x plus 16, factors of 16, that will add up to 8. This 4 will always be that number that works out, a 4 and a 4, so we can just say x plus 4 squared. I mean, what we're avoiding is we'd say, oh, it's an x plus 4 times an x plus 4, but we would end up with writing it in this form anyway. And then combine your like terms, negative 16 minus 3, so minus 19 equals 0. Now we get to solve. We completed the square, and now it allows us to solve. So the way that we solve this is going to be by using square roots, which is something that we did last term and a little bit in 4.6. So solve by square roots. We have our x plus 4 squared minus 19 equals 0. We'll add 19 to both sides. And now we're ready to undo our square by square rooting both sides. So this leaves us with an x plus 4 equals, don't forget to bring in your plus or minus, square root of 19. It's not a negative 19, so we don't have to worry about bringing in I. We'll just leave it as a square root of 19. Last step, let's subtract 4 from both sides. So x equals negative 4 plus or minus the square root of 19. The negative 4 and the 19 are not like terms, which is why we have to leave them separate over here in our final answer. But that allowed us to solve for x. So the reason we split this into 2 days, what you guys saw in all the examples, or what you're going to see when you do the homework, everything is going to be when a equals just a 1. The second night that you work on this, we'll throw in other values of a. There's just 2 extra steps involved in completing the square, but we just wanted to get the method down first before you had to worry about those other numbers in front.